Hi, welcome to Acids and Bases Part 5. My name is Dr. English. Today we're going to be briefly talking about acid-base indicators. Specifically, we're going to be looking at different types of acid-base indicators, how to use Table M of your reference table, and some examples using Table M to bring it all together. So what is an indicator? Indicators are substances that change color when exposed to solutions of different pH values. So it's going to change color depending on whether it's placed in acidic solution or basic solution. Table M of your reference table lists several indicators, the pH range at which they change, and the color change they undergo. By testing a solution of unknown pH with more than one indicator, it's possible to determine the pH of the solution. So here is Table M of your reference table. They list a column of indicators, approximate pH range for color change, and then the color change. But really seeing what this looks like is important to understanding how to use it. So here's a breakdown of some of the indicators that are listed on Table M. Phenolphthalein was a little hard to use because obviously at one end it's clear. So let's look at the indicators that actually have colors associated. The first one is methyl orange. Now methyl orange has a pH range of 3.1 to 4.4. So what does that mean? It means from 0 to approximately 3.1, we're going to be in this red range. And from approximately 4.4 all the way to 14, that's going to be yellow. So it's important to say that it's red to yellow, but there is this little distance between the two of them where the two colors mix together. And there we'll see a mix of the red and yellow and basically orange. So if I was to give you a question like, okay, I have a substance, it has a pH of 7, what would the color be if I used methyl orange? You'd say, all right, I'm going to go to 7, I'm going to go down, it's going to be yellow. Let's look at a different one. Bromthiamyl blue. Bromthiamyl blue has a pH range of 6 to 7.6, and it's going from yellow to blue. Again, from 0 to 6, that is where we're going to see this yellow. From 7.6 to 14 is where we're going to see the blue. The change in color, the actual spot where we'll see a different color change, differentiating in this case from something that's more acidic and more basic, will be in this range right here, where we'll see a green color. So again, you might have a question that says, what color will bromthiamyl blue be in a pH of 5? If it's 5, it's yellow. If it's 10, it's blue. Or what would be an ideal indicator to use to see a pH change going from 5 to 8? Well, bromthiamyl blue would be a good use of that because you could see initially if we started at 5 that it would be yellow, and then we'd be transitioning up through 8. Litmus paper is another common type of acid-base indicator. Litmus has a range of 4.5 to 8.3. With from 0 to 4.5, we see red. And a lot of times we think, okay, litmus, red, acidic. And then from 8.3 to 14 is going to be blue. And again, we think blue, basic. And in the middle here, we might get a purple color, which is the blurring together of the red and the blue. And that's more neutral. Bromcresol green, we don't see that often on exams, but it's good to know. It has a range of 3.8 to 5.4. From 0 to 3.8, it's going to be yellow. From 5.4 to 14, it's going to be blue. And then in between these two values, again, we're going to see green. And then finally, thymol blue, very similar, but a different spot of transition. From 0 to 8, it will be yellow. From 9.6 to 14, it'll be blue. And the middle there is going to be green as it transitions from one color to the other. And again, these are very good to use if you have an unknown solution. You can use multiple indicators and sort of help you pinpoint what the pH of that unknown solution is. Let's look at some examples using Table M from your reference table. Which indicator, when added to a solution, changes color from yellow to blue as the pH of the solution is changed from 5.5 to 8? So the first thing that you need to do is you need to find which indicator is going to turn from yellow to blue. And in our world here, there's only one, pretty limited on answers here. Yellow to blue. And it's saying the pH of the solution is changed from 5.5 to 8. Well, this is 5.5 down here, so that's prior to 6. 7.6 is the shift to blue, so we're looking for 8. So the 5.5 to 8 falls in this range. Bromothymol blue would be our answer for this particular question. Which indicator is yellow in a solution with a pH of 9.8? So we want to see a yellow color around the basic end. So now again, let's look at our answers here. We have methyl orange, which is changing from red to yellow, so that's a possibility because that yellow is over towards the basic side. Bromothymol blue is not really an option because the yellow is more in the acidic range because it's going from yellow to blue, and phenolphthalein is going from colorless to pink. So it looks like methyl orange might be our best option because of the yellow in the basic area, but we want to check back with our pH of 9.8. So methyl orange is from 0 to 3, it's going to be red, and from 4.4 to 14, it's going to be yellow. So methyl orange is our answer for this one. Methyl orange is correct for this answer. A solution with an unknown pH is tested with phenolphthalein and turns bright pink. Is this solution acidic, basic, or neutral? So let's look at phenolphthalein. Phenolphthalein has a pH range of 8 to 9. So from 0 to 8, it's going to be colorless, and from 9 to 14, it's going to be pink. Then we have these 3 other columns, which is sort of interesting to look at. Lower end of the pH scale, so 0 to 7.9, it'll be clear. 8 to 9 is a light pink, that's our transition stage. And from 9.1 to 14, it's going to be bright pink. This says it's going to turn bright pink. That means if it's falling in the bright pink range, and that's 9.1 to 14, then this solution must be basic. Another solution of unknown pH is added to the bright pink solution. As the solution is added, the original solution turns from bright pink to clear. How would you classify the pH of the solution being added? So we're starting out with a basic solution where it's bright pink. We're adding another solution, which is making the current solution turn clear. The clear color range is from 0 to 7.9 in terms of pH. So I would say from 0 to 7.9, if it's turning clear, we're looking more at an acidic or potentially neutral solution. So I'm going to acidic, potentially neutral, because this whole range goes from 0 to 7.9, and we know that 7 is neutral. So what did you learn in this tutorial? We went over the definition of an acid-base indicator, we talked about how to use Table M, and then we did some examples using Table M. Need more help? Feel free to contact me. Have a great day.